Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. Younger Dryas, Glacier Ice Boulder Reentry. 12,900 years ago, there was a great extinction in North America. The extinction coincided with a period of global cooling that lasted 1,300 years, called the Younger Dryas cooling event. The glacier ice impact hypothesis, published in 2017, proposed that the Carolina bays were created by the secondary impacts of glacier ice chunks ejected by the meteorite impact on the Laurentide Ice Sheet. The impacts of the ejected ice chunks produced seismic vibrations that liquefied on consolidated ground, and the ice projectiles created inclined conical cavities that were remodeled into shallow elliptical bays by viscous relaxation. The expanding vapor plume at the impact site accelerated the ice chunks ejected from the Laurentide Ice Sheet and sent them in ballistic trajectories with launch angles averaging 35 degrees and speeds of 3 to 4 kilometers per second. Approximately 1.5 trillion cubic meters of ice were ejected in suborbital space flights by the extraterrestrial impact. Depending on their size, the ice boulders had kinetic energies of 13 kilotons to 3 megatons of TNT. Chunks of ice as big as a baseball stadium plunged to Earth at 11 times the speed of sound. Atmospheric ablation of the ice boulders produced vapor trails that blackened the sky. The impacts produced shock waves that liquefied on consolidated soil. The ice boulders formed inclined conical cavities hundreds of meters wide that quickly transformed into shallow elliptical bays on the trembling, liquefied soil. Today we can see the result of this saturation bombardment using LiDAR images of Nebraska and North Carolina that revealed the Nebraska rainwater basins and the Carolina bays. It is known that atmospheric drag and gravity in the presence of ablation interact to slow down a constantly shrinking projectile and make its angle of impact more perpendicular to the surface. This video examines the premise that the ice boulders ejected from the Laurentide Ice Sheet survived the reentry through the atmosphere without completely melting. We can estimate the time of reentry of the ice boulders by using the angle of impact derived from the width-to-length ratio of the Carolina bays and the 100-kilometer thickness of Earth's atmosphere. The oblique transit through 174 kilometers of atmosphere at 3 kilometers per second requires 58 seconds, and at 4 kilometers per second, the transit time is 44 seconds. This means that the glacier ice boulders had to withstand approximately 1 minute of ablation and heat during their re-entry. The Space Shuttle Thermal Protection System protects the Space Shuttle orbiter during the searing 1,650 degrees Celsius of atmospheric re-entry. This temperature is slightly lower than the 1,995 degrees Celsius produced by a propane torch. This provides the opportunity for conducting an experiment to see if a chunk of ice can withstand the heat of a propane torch for 1 minute without completely melting. The equipment for the re-entry experiment consisted of a chunk of ice, a timer, and a propane torch. The piece of ice was weighed in a kitchen scale before the re-entry experiment. Its weight was 388 grams.
We're now in the re-entry phase, going through the atmosphere, experiencing the high heat of re-entry. The high heat vaporizes some steam. The ice piece has survived re-entry, and with much to spare. This is the ice piece that remained.
The ice lost only 38 grams after being heated with a propane torch for 1 minute. This is a loss of less than 10% of the initial weight. This means that it is plausible that ice boulders ejected from the Laurentide Ice Sheet by an extraterrestrial impact could have survived re-entry through the atmosphere to produce the Carolina bays and kill the North American megafauna in the process. This experiment has shown that ice is quite resistant to external heating because it is a poor conductor of heat. We can also deduce that heating an ice chunk with a torch produces a layer of steam that lifts the hot shock layer gas away from the ice and protects against melting by evaporative cooling. It is also important to consider that the Carolina bays were produced by a saturation bombardment of glacier ice projectiles, and that the close proximity of the projectiles as they re-entered the atmosphere could have decreased the ablation of the projectiles that traveled behind others. Drafting, or slipstreaming, occurs when moving objects align in a close group, thereby reducing the overall effect of drag by being in the lead object's slipstream. Some people may think that the propane torch used in this experiment was too small. I would suggest to anyone who doubts the results to repeat the experiment with 2 or 3 torches at the same time and report the results. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.